Okay, good morning. We're going to have two lives related to Geometrikap today. One, since this point of time, until my lunch or something, something else. 1 hour, 1 hour and a half. Uh, Then I will have my lunch. Then I will come back with 3 hours and a half of Geometrikap, and that's it. So this time around, let's not put an alarm because the alarm is my meal. Alright, let's. From private. This is a elixir. The static website disguised in a Phoenix web framework application. In order for us to be online, with the generosity of Gig Elixir, this is great. Oh, I didn't open. Oh my god. Okay. I didn't open the folder. I only opened the code. Okay. Besides, I have this light from the outside. In, I'm not turning the lights. Maybe I'm not doing the live before after my lunch because it is a cumbersome. Maybe we'll play guitar and then do the live in the night with the lights with the light on, like starting at 8 p.m. till midnight. So we have 4 hours of Geometrica. And at some point I will shut up because people will get to sleep at 11 p.m. Mm, I don't know. We'll see. I probably will close the window, but if I close the window, then you will not be able to see me. By the way, in here is in order to work, it's okay. Well, don't think that it's too dark in here. It's the camera, most likely. Only in the afternoon, like at 5 p.m., then it's things get crazy. But still, I don't know. I don't know, as always. But we have this, and we have the codes, and we have been for 5 minutes without doing nothing. But if you're an employee that you haven't had the opportunity to find your first job, this is what people do. They arrive and they, in some places, not in every place, they arrive and then they go to do some breakfast and spend 1 hour, and then only after that they write. Because maybe they have a meeting, the ceremony, a scrum meeting, and then they leave. And it's the same in the public sector. But some companies they do have very well structured, very well structured. So some of them the software industry is known to be very flexible with the people, with the employees. Yes. Well, if you are in your own, you need to do these things right away. I'm not getting paid for doing this, but if this was some sort of freelance project or contract, from the morning I will be doing this without hesitation. I have shown that I proved that in the past. See. Uh, so yeah, what else? If some people see this video and know what I'm talking about, they will be like, because they know. Okay, we have this thing that is, we are being cool with the user. Look, this is 45 degrees from the user's point of view. From the user point of view, yeah. We can request the user we can tell we can, of course we can, but that will be a little bit too much to request the user to say, hey, from this point of your life, this is 45 degrees right here, buddy. Look at this. This is your 45 degrees you're looking for. You were thinking to get this, you were so wrong. In the web browser and the Canvas API, this is the new thing. And the user will say, okay, let me learn that because I will do more top-down geometry in my high school. I will do this like my notebook. Do this in your notebook and then turn off the notebook and it will be okay. Uh, Come on now, this is for the users. The users should have it easy and uniform experience in other areas of their lives. Uh, so this is 45 degrees from the user point of view. We are doing a lot of things on the background to make this possible. Just some calculations, some relations with the angles. Okay, so this is 45 degrees, and this is the positive side. Well, there is some offset in here when we are observing that this thing gets a little bit, it goes a little bit really, and I want to know that. I don't care if this take me the entire year, and I understand why some sort of technicality of the JavaScript or the Canvas API. If I got some of that, some implementation, some little detail related to the Canvas API, or if we are doing some miscalculations in the circle, or if I really want to know why is the case that this thing should behave uniform in the equations, in the notebook, in the formulas. Or in here, we are having this little bit of translation. But then again, we have this float storage number, and if it's related to the floating point storage, then we will say, okay, we will try to find the fluctuations in the offset only after finishing the application. So how can we know this? Let's apply. So let's apply. We have this and we have this. Let's apply some transparency to the vertical, the horizontal line. Yes, but I don't know how to do that. And code. Oh my God, what is this? Made geometry, geometrikap. And code is not able to even do a well request somewhere. Oh yes. Oh yeah, I need to shut up. So this thing is able to help you. You have an image, you have your, this is the x, dy. This probably are the source of the first, of the corner point of the image, the starting point of drawing, which is this. And let's see if there are, if there are some overloaded methods. That's when you want to know your theory of programming. And they ask you this in the interviews. What is overloaded and what is overridden? Then you come up with these answers that you know. But some people doing some other programming languages, uh, they implement things and left the details for other people. So again, oh my God, the corner point, the starting point of the image, the width and the height. We can write that. I want some transparency. And here we have, this is different. I don't understand this. This this is what we already have, X, Y with height. But then we have this. Well, we don't know how to apply a transparency. Maybe a transformation. So we're going to ask Google. And if it's not, if it is too much code, if it is not a call to a method, we will we will design a transparent image with a class effect. So canvas and draw image. Oh my God! With I used to have a great keyboard from Penclick. I really like that keyboard and the effect of I mean the interaction of the fingers with the keys. But they closed the company. They are not selling those anymore. I can't believe it. I can't believe it. Now this keyboard, it was one of my experiments or explorations. It has this thing which the option is here and the command is then click keyboard. Here it is. So no more pen click keyboard. So this was the thing. These things were great, and they include some ports for here. Well, more than anything, it was the I don't know if that's the correct English. More than anything, probably yes, because it's a song. More than words, more than anything. You know, how can you say the human hardware interaction? And it wasn't noisy. Uh, yeah, no noise from the keyboards. So far as I remember, I haven't really somewhere. What I'm saying this anyway. Oh, because I did have to press very hard the key in order to respond. And the keyboard from the MacBook. This is not a MacBook, but I like the hardware interaction. So these guys almost got it right. The Apple keyboard. Well, they are like in lead in the knife. Well, the pen click does not have lead. It's not lead. It does not have light. So maybe you should work with a lamp in the knife. Or maybe you should not work in the knife. I don't know. But it feels good, the Apple keyboard too. Global Alpha. Okay, we have this. Now, this is indeed a call to a method, an invocation to a method, but it is on the context, not on the image. But it's okay. We just want to see what is happening with the rotation. So hopefully someone is not having it's finding it's right. Now alpha chant. It's good if you invoke the method and know a little just a little bit of the thing. So probably you know that some image have some alpha channel in which you can establish or set the transparency. So they are doing it on the context object in all the drawings. So let us see how this thing is going to work because it's good that we have the same image and everything everything goes martial arts, as they say in Ranma y medio. Ranma y medio? What I'm talking this Spanish, English? How do you pronounce this in English? Ranma and one half is this? It was this anime famous in the English speaking regions or geographies? Ranma and a half. How do you say that? Ranma y medio. So they have the motto, everything goes martial arts. This is a great principle for an anime. Everything goes martial arts. And I don't know how they came with this idea, but everything goes martial arts. Like it seems like something that you can work and build a story around that phrase. Everything goes martial arts. Every single life scenario it becomes an opportunity to get into martial arts. But maybe that's not the whole point of the Ranma. I don't know. Uh, okay, so nothing's here. There was a rectangle over here. There was a rectangle over here. So this thing went crazy. Uh, this thing is working. It- oh no, this thing is not working because this is the rotated image. Let's see this thing. Opacity, fully opaque. Yeah, we should. Oh my God. At least we know because we don't know if one is. Let's suppose one is. But still, this is not transparent. So let's turn. Let's switch the values over here. Nothing. So let's see. Oh my God. CTX global alpha. Canvas. Oh, property. Oh yeah, it's a property. It's not a method call. It's a property. Okay. This is a method invocation. And here we are setting a value. Okay. Now I got the flu. I don't know. I didn't want to be in the hammock anyway. I cannot be. Uh, even when if you have some if you're ill. Okay, 0.0 gluten fine. Fuel pack. Inclusive. Drawing translucent shapes. Okay, we have this. So this is translucent, as they say. I cannot see. Oh, here it is. I don't think this thing is working. They set up the global alpha to 0.5. Was um, okay. Look, this is opaque. We're unable to see. And the blue is very solid. Now, look at this. I cannot see anything. Um, oh, the rotated one is in front. This is in front. This should be the fake. Okay, look at this. This is beautiful. I was about to design some this fluorescent, like Tron Legacy, the movie, the effect. Uh, things like this, something like this effect from image. Because it will be cool in the dark. In the dark, we could have that straight edge, so people feel more appealed. To hey, we don't have wood straight edge. We have a futuristic straight edge. So I want to do geometry now. This tool from the future, which is a tool from the past, but with light. All right. Okay. Uh, okay. It is a little bit silly. I'm not sure about the length of this line, but the point. should be here. That's the proof. Uh, I don't know about the line if it should have the same length of this. Most likely yes, but this point indeed should be here. Why is it moving? I hope it is for because of the floating point arithmetic. I really hope that because then we can say, okay, for this scenario, there have been some tragedies in the past that I would like to mention. 5 floating point arithmetic error. I don't remember if this. Okay. The Ariane 5 rocket explodes due to a floating point arithmetic error. This is tragic, you know. Probably some people lose their lives here. It's unfortunate. Look at this. I was reading this. This is a famous error if you're in the computer systems. That's why I don't mess too much with these little numbers. They some small numbers with floating point. But maybe you are into finance. Imagine making a person lose their money. That would be that would be a bad place to be. You know, a bad spot to be. So if it is because of and there were more errors because of more tragedies because of the floating point arithmetic calculations, and we are doing some rotation in here. Or imagine simulating a game like think of any video game and you're doing this sort of thing, the user will complain. They say, "Hey, come on! I am targeting to this. So let's have Crusader of my. I don't know which kind of video game you are up to, but Castlevania is a good one, a famous one. Imagine this guy. Oh my God! Imagine this guy. By the way, these images are copyrighted, and don't blame me. Just using. I'm not posting this anywhere, but I am showing them. Okay, Castlevania. So imagine this guy, you're in charge of programming the whip for this guy, or hero, Leon Belmont, and you came up with these little offsets that maybe accumulate over time, like this rotation, that as the angle increase, the offset also goes crazy. So imagine this guy being targeting a whip. How do you say a lash? I learned that from the Lord of the Rings. Probably lash. Yeah, lash. Uh, and then the skeleton is located at 90 degrees from your view, and then you whip at 45 degrees. That is too much. That is an exaggeration. But let's suppose you have this little bit offset, then you will miss the. Um, you will not be. Your hit will not be critical. You will decrease the enemy's gouge by a lot. So this you should be happy with this. It is acceptable, and people can live with this and do geometry because this is a tool. And when you are in geometry, when you are uh, using the straight edge of the ruler, you place it in some place, then you rotate it, but It should be precise. It should be precise. We need to fix this because even if you are rotating this thing on your notebook, you are not doing this. You say, okay, let me have it like I'm targeting 45 degrees, but let me have this little offset. Imagine giving that tool to some architects, you know, how will they design speed their buildings? You know, we should not accept this. Most likely the user will not know, but we will know. And I cannot go in life knowing this. I will not be able to sleep at night. Delivering you this. We are going to try to fix. We are going to try and fix this. But if it is too much, we will ask for help. We will ask for help. What kind of help? Uh, uh, some. I'm sorry. I'm you know, I shouldn't have done this live. But I'm not sorry. I'm a little bit ill or sick. The good thing is that I laugh too much of myself. Um, what kind of help? Uh, hmm. Uh, um, we should look at existing libraries and see how they do the rotations. Open source library, open source libraries, and see how they do. But you know, when you're reading this code, I have tried in the past. It is since it is a full application, it's a little bit hard to really put the concept in the most simple way. That's why if we manage to do this, we are going to upload this sort of quote unquote library so people can see at the core how a rotation is happening. Uh, uh, which not make me a better person. Those applications are fully fledged applications. And they are not intended to be pedagogical, maybe, but it is good code, good written, high quality code. So now we know this. This, I think, this should be here. We will try with 90 degrees and then leave for. I need to take 1 minute break. So where we were talking about, this is better. For me, it's better to be talking instead of doing. It's more funny. I don't. I get to not do anything but talking. And maybe criticizing is easier because you're not doing anything. Some other people are trying to build something, and you are just sitting on the chair and hey, this is wrong. This is wrong. You should do this. You should do that. It's very easy, not owning anything. That's what Steve Jobs said in the conference. The videos are on YouTube. You know, the consultancy is all about how things should be done without them doing actually anything. Uh, so maybe these little breaks, we should own them. We should say we cannot go live with this offset. We'll ask for help to some expert in mathematics and computer graphics. Not computer graphics, maybe Canvas and Canvas API expert. On the forums, we can ask questions. Hopefully, someone will help. But first, reading some books. Not again in trigonometry, but in computer graphic books, they have preliminaries on the mathematics that you need. Maybe they have a chapter on rotation. Most of the time, those books implement some game engine. We will taking a look everywhere. But I think we can move with the building of the user interface. We continue with user interface controls, which will be a little bit, I don't know, because those are outside the canvas. And oh my God, that will be another thing. And then drawings, and we are done. So expect for this to be finished 2013, since we are talking too much. This should be sitting on the edge of screen. Well, you have the idea. I don't know if you are familiar with this game. I don't know what kind of game people are playing these days. Maybe you're aware of Shadows of the Colossus. Imagine this funny. Imagine this guy, Wander. Where is Wander? Here it is. Our beloved hero that got into some deception, victim of deception, by ignorance, by love. Uh, so this guy has a bow, have a bow over here, something. Maybe it's here. The bow is here, you know. But if he's too fast, that he can he take the bow very quickly from his back. You know, simulating start placing the bow here and then go and pick the bow. It will be too much of a experience. He can travel with the bow and place it here when a battle arrives, and go and pick the bow. That would be a realistic fight. But maybe the user don't want the reality. Maybe the people want some fantasy in their video games. I don't know. But let's stop talking and go to the point, straight to the point. So this guy have a bow. If they throw an arrow to this fellow, this is the tree. I don't remember the name of this guy. Actually, I don't remember the name of any of these. This is Malus? No, that's the 16. Well, we have one quadrant. Maybe this quadrant. No, this is the one with the long beard. This is the 6. There is quadrant, there is Malus, but we are doing this Malus. Maybe this is quadrant. I don't remember the name of this guy. So let's go straight to the point. I'm just procrastinating. Uh, Here is a good example. Imagine you have to throw an arrow over here so he can place his hand on the shoulder, and then you go uh, on the chest. Then you can jump into this part of its neck and go here. Probably no spoilers. Probably no one is playing this game. But I do hope you have played this game or give you a chance to play this amazing game. So imagine this guy targeting with the arrow this for this point, and the arrow always go this way because of your trigonometry knowledge, trigonometry, and you're always throwing arrows at here, which is some sort of stone, maybe. And you'll never get into this area because of someone said, it's okay, let's go live with these little numbers being a little bit offset. So this is the kind of errors that you can deliver. This is the kind of experiences that you can deliver without if you allow yourself to these sort of things. Okay, now that we have exemplified that we need to have this here, if it is possible, I don't know, I am an ignorant person. I know how to write REST services. Don't start with the thing. Don't start with the criticizing. But this is very different. I know how to call a REST API, grab the JSON, and if I don't remember, then I will look what's the method invocation to JSON for the JSON path. And then extract, at this point, the libraries for the JSON interaction, it's very well, very sharp and have very well. Um, it has been a lot of years since this the usage of this, so it's very uh, also depends on your language. How can I? What kind of work can I use? I have very refined libraries. Like we can do that. We can do some database. Let me have some. Let me go rock and roll, as Kiss say in its song. Let me go rock and roll. So let me go and do something like this. I'm not getting paid for this, but I have a lot of fun exemplifying with this. Now the other thing, the rocket explosion, that was a tragedy. We, we that's not funny. Well, this is funny, and there will be more examples with some other games that you maybe know. Imagine, use your favorite game, use your imagination with whatever. It cannot. It doesn't have to be with throwing stones or something. It can be jumping into a platform. You know. Okay, but the happy time is over. Now it's time for some thinking and exploration. Only 8 minutes. The good thing is that we are going to have 4 hours later to really explore this thing. Maybe we should explore this for an hour and then tomorrow do the user interface. And uh, by the end of the week, we should be drawing. But today, maybe we can try to fix this in 4 hours, or at least find something I can do 4 hours today after doing 4 hours guitar. So this will be in the night. Probably you will get to sleep. If you are in the other part of the world, you will be sleeping. But the YouTube video will be there. Okay, so we have this one. Now let's try 90 degrees. I don't know what's happening here. If I, maybe if I were an expert mathematician, I should know exactly why is this the case and why and where have the numbers go wrong, which is great for a song title. Where have the numbers go wrong? And what's going on here? Maybe the relate. Maybe some mathematician knows. Okay, this guy is targeting for this one. But it's here. What happened is that uh, he's missing some sort of look. There is this. little distance that we draw in the past. Here we have something. We have, oh my God, we have this little distance because the point is almost at the line. This point also from geometry in the books, you get that the finer the line, the sharpen, the sharper, the sharper. Vamos a recordar. We have this list on. Maybe we have something in here. Remember that we did have this, and we were adding something. So maybe this is something that we can consider. Now imagine that we fix this in this hour before I get in my lunch, my meal. That would be great, right? But someone will say, stop the fantasy and the imagination and get to work. But let's never stop imagining and the fantasizing. That's a great source of beautiful work that have been achieved by humanity. So never stop imagining. Uh, don't let nobody say to stop fantasizing. And okay, I'm saying this word. Sharp, yeah, meaning this then is sharper. What is the superlative of this sharp? The sharpest. What's going on with my English? The sharpest, not the sharper, not the sharper. And why this? What are these suffix have to do with the words? Suffix for English words. Okay, this is for adjective, comparative adjectives like taller, faster, teacher, runner, minimal, on the computer. Okay. Also is for adverbs, which I forgot about this even in Spanish. Uh, I don't think no one knows how to speak while they are speaking. Uh, yeah, this is a good deal. The language is a good topic, great topic. The language as a communication, as a via of communication, as a medium, that's a great deal. A great topic. How to communicate and what do you want to communicate? What is it that you want to communicate? Your feelings, your ideas, and what are your feelings? How do you encode feelings? Is it right? So we are in the AR. This is for adverbs, comparison. And then we have the superlative for sharp with the sharpest. So the sharpest uh, point of your pencil, the better for your geometry exercises. because because and here I would like to have for the intersection point to be more maybe shining or something. I am here, but I hear that someone is selling something, some bread with ham inside. That should be tasty, but I cannot go running. I can fail. So don't run whenever you're trying to. I don't know. Do whatever you want, but be safe. Okay, so 0.5. This is too much. I don't know which one is the transparency one. It seems like the intersection point is on the horizontal line. I think this is good. So the transparent is the rotated one. So let's do 90 degrees. Why is this happening? I think we need to do more drawings. What is working for 90 degrees? Maybe we can add exception for those angles at 90 degrees, like 90 degrees, 180 degrees, and 270 degrees. So, so let's do 90 degrees. How is that? Uh, what did we said yesterday? Let's do 45 degrees. This will be wrong. Remember, we did have 135. But let's see this. Just to see this. Look at this. The point. So it is rotating. And there is a circle. Oh my God. There is a circle. The one was over here. So there is as most likely there is a circle and the values are fluctuating in this. Here we have 60 degrees, 45 degrees. Here we will have, Let's do the 45 degrees in the fashion for the user, which was this and this. Okay, so it's coming closer here. You see, there is a little circle over here. But it was a great hour. Let's do this. This is down here. Look, we need to. Well, there is no ruler here. I am hungry. Well, there is this distance. Let's use. Let's use this word because it's with a B, so we can find it easy. Vitral is from again from Castlevania. The T should be Veritas or Vitral. Is the things that are of the church decorations, church decorations. Okay, we have. Oh my God! Is this Veritas world? Veritas world is coming over again. Um, on my head, so I'm gonna stop doing this application because that only means that I like more talking about Veritas world and maybe focus on Veritas world. So if this Veritas world, it's coming all over the place to my mind every time. Look, we have 90 degrees. This is 90 degrees and this is 90 degrees. So at least the rotation happened uh, in a correct way. It's here. You're seeing it. Uh, but the center of turn, the center of rotation is not well calculated. Uh, what can we do? I'm procrastinating right now. Also, I'm coming all over the place with Veritas rule. If this continues to happen, I will stop doing this for the treatment of my learning and the propagation of the geometry content because uh, no need for me to do this. Is this Verita word is all coming in my brain all over and over and over and over. Then I will say, okay, I will stop and I will do the Veritas world right stuff because this is not good. I'm telling you, I will do that. So let's hope for the Veritas world thinking to stop. But now it's transparent. Now I'm able to see. No, this is too much. It is way beyond the center of here. Look. But this is the pixel. Remember, we can allow this for ourselves. This is remember the plus one for yesterday. This is this is the plus one. We can live with that. I will not feel uh, bad. I will not feel bad about it. Instead of hard coding the plus one, we can if we hit this center of rotation, this guy, we can go live with this. Because that's it's people can see it. But if you are talking about video games and other simulations, this is not determinant. You can really hit the Colossus with this thing. Mm, this is silly because yesterday the 90 degrees looked uh, in position as far as I remember. Mhm. Let's close this. 1 hour and a half. No, 1 hour, 10 minutes. We're going to leave at 1 p.m. I don't know if I'm going to come back to another live or play the guitar. What do you think is happening? Let's not move the radius. Let's move the coordinates. We are saying in the code, not what we want, what we are saying in the code, what we are expressing. What we are saying in the code is there's this radius, find 90 degrees, and then find this, find this maybe, and say no, no, this is not what happening. Let's continue with our thinking, and then most likely find this one because we are not starting from here last. We have removed this addition. Well, let's see the code. No, but we have this thing. Oh, that's the reason this thing is failing, at least for the 90 degrees, because the 90 degrees works. That was a little bit silly. And now we have this. Now we can work with. Now we can say. But still, yesterday it was. The thing was fixed. We will have to rework to redo all this arithmetic. And we have this little thing. Because I'm not sure if we are targeting this line or this line. Or this one. We find this. But actually, I don't do that. When we have this, when we have this, let's say if we find 90 degrees, we found this. Then we say rotate. We translate it to this point. Then we say rotate 90 degrees. In 270 degrees. We are wrong. So we are not getting something. Uh, Yeah, we have, and we can prove it. We're going to move this. We are at 0, 0 here, apparently. We're going to move this 10 on the positive. So we can prove that we have our drawing correct, that we have translated over here, that we have rotated, and that this viewport corresponds to 270 degrees. We are going to add 10 to y. It is here. Should be 5. Uh-oh. At least we moved it. There's something wrong with our perspective, with our appreciation of the viewport of the canvas and its rotations. And I would like to understand that more than something else. I will really want to grasp the concept of the top-down uh, viewport and its rotations to have it in my mind. Only means that our drawing for the 270 degrees is wrong. So more experiments to come. So this is wrong. This is life. This is not like coding. This is building geometric up and learning so much stuff along the way. Maybe more suitable for sitting on the edge of the ruin. I'm not sure if I will do more exercises on the Canvas API. I'm not building a game on the Canvas API. What we will do, if this thing is used by at least 100 persons, no, at least 1,000 persons, uh, let's go with 100 persons because it's in the Bible. Let's go with one person. If one person sees 300, if one person sees 10 short videos on geometry and use this software, then I will start the affine geometry section and the symplectic geometry, which will be hard. Those will be really hard to implement. I cannot say let's hope for 1,000 users because maybe there will be 2 users, maybe there will be 5 users, and they deserve to have the right tools. Let's suppose there is a new science and there's only one person or an old dying science, an old dying science, dying because some artificial intelligence, maybe. And there is only one person doing that science in the old fashioned. That person deserves to have tools to continue with its quest, with his or her quest. It's in the Bible when the guy say, "Will you forgive this town if there is only such amount of good person?" And then God says, "Yes, I will." But I'm not God. What I want to say is that I'm not expecting for this to be used by 1,000 people, 1,000 persons. If only one person is doing geometry with these videos and this software, that will be enough for these health and guys and Tatiana Alexeyevskaya to say, okay, so the book made it into into a software. Uh, and now, from the content of the book, there is this new way, old way to exercise geometry with the fingers, like drawing lines in the sand, you know, on the beach. And you can have instruments when you go to the beach. Hopefully, you are going to see the ocean and not doing geometry on the beach. But you can do that or whatever. But now with the same idea of drawing lines on the earth, now in your mobile device, if only one person does that, then I will feel motivated to go with affine geometry and symplectic geometry sections. But still, I want to grasp the concept because I would like to go into the 3D world eventually. And this will really help me because that is another kind of field. We can do this and forget about the problem. Probably -5 or -8 is okay. And then we have this little fellow over here. The little one, remember. Well, it's okay. We can say this is totally fine. You see, probably one. Now it's now it's here. Look at this. How beautiful this looks like. This is the rotated one. Now this looks beautiful. This transparency and this wood effect that we have over here. This material from Blender and these little marks like people having some how do you call that pencils with like how do you so the one with you writing this. Let me see if you're able to see on these things markers. I don't like Veritas World coming into my mind. Markers and one. Oh yeah, markers. And you see, we look for that because we cannot know everything. We have to look for this global alpha property. Imagine a person knowing every property of every object in JavaScript. That will be crazy. Uh, okay, I am about to leave. Let's try this. It seems like it was like this. I don't remember. It was like this will be gone once. Okay, we have it. Okay, see you later. We will do more rotations, experiments. We will try to encode this into the formulas instead of to be at 0, 0 here. Uh, Nothing wrong in starting in here, but this will probably accumulate In the drawings, we have 7 lines, seven lines. Uh, uh, Probably this will be cumbersome. We are targeting at 0, 0, and introduce these numbers somewhere over here later in the night. And also, since we are going to be 4 hours, I would like to do some animation of this thing since we already have the loop in place. And go. There is a loop in here. We can do an animation adding one by one, and with that achieving the mapping of the angles and its correspondence with the other angles in the other quadrants. You see, several things. Well, that will happen at the night. For now, I feel like I don't feel now because we were tempted to say, okay, let's have this thing have this offset, right? And so the people can live with that. But what kind of software engineer, what kind of computer programmer, what kind of overall craftsmanship will that be? We should try for this. And I suppose there is a little bit something in here. But that's too much. I need to shout out because maybe we will not be able to introduce these numbers over here somewhere in these formulas. And then we showed the video games. Talking about video games, let's finish with some video games and some fun. Like, let me think. The only games that I have played. Now, let me see. Well, Castlevania, I like Castlevania. But I only have played 2 or 3. Which one? I haven't played too much video games. That's one again. Final Fantasy. It's up to you to come up with your favorite video game, uh, an example of how some calculations will have some other effect in some action that you're doing with your character. Think of your favorite video game, especially if it is related to some rotation. Maybe you will have a lot of examples. Um, these mathematics are beautiful. People building this infrastructure for us to appreciate this, to do some. But we really have this line of these two related to trigonometry. But it took us a lot to arrive here. We could have this from the internet right away. Like, uh, well, we did want to make the journey. Let's explore something. And we are also refraining ourselves to not go in every direction because then someone will say, now let's explore the alpha channel. And let's not. We are just accepting that this exists because we are focusing on trigonometry. So at the end of the day, I am a person who is able to focus, even when it has been said that I am able to focus. But I am able to focus. This is pure math. high school math, and we're not going here. But I like computer graphics anyway. So imagine the guys programming the alpha channel when they saw the results of the transparency, they felt very happy about the results. They say, okay, I have the image and I have this opacity or transparency. I don't know. Okay, now what? Uh, what video game? Well, Final Fantasy 16. But in which part? I don't want the example to be related to weapons, or throwing bullets, or stones, or arrows. But I cannot think of another example. There is a Tekken Ball section in Tekken 7, but you are throwing something. You're throwing a ball. There is a projectile. I don't want to put an example of that either. But then I am thinking, then maybe mathematics is related to movement. There are no stationary mathematics, and mathematics describe the world that is always moving, always changing. So I'm not that acquainted with more games in order to have some movement. There is no stationary math. Perhaps arithmetic. No, you are moving something, you are changing quantities, you are increasing something. So I don't know. I don't know. Let me think of a video game. Prince of Persia. Um, there should be. They should make another game with this guy with this age. Who is going to face Noctis with all these skills? Oh, but these guys are fighting some sort of these creatures. Okay, Mary, you're designing the hair of Noctis, and you want an angle for the haircut to be 45 degrees, but you're allowing yourself this little offset. So Noctis will have maybe this guy. Uh, his his haircut is 90 degrees at this side. So if you're a designer and they give you a computer program to design this guy, which I forgot his name. This is Gladius. Well, I forgot the name of this guy. Okay, let's focus. So you are a designer, and they provide you a computer program to design the hair of this guy. Let's be respectful and let's recall the name of this fellow. Fantasy 15 characters. Oh no, please don't just put the names. Don't make me read all of this. Okay, so this should be okay. Japanese Gladius. Gladiolus is not Gladius, it's Gladiolus. Okay, Noctis is Noctis. Ignis! How can I forget about this guy? There is an Ignis in the King of Fighters. You should not forget about Ignis. Look at this. Oh, this is with a C. So maybe you can forget about Ignis. Maybe it is Ignis, but it's Japanese. I don't know. Or maybe it's English. I don't know. So there is this guy, Ignis. Don't forget about this. Ignis, it's everywhere. Not everywhere, but at least in two games. This is very powerful. You know, if you're a teenager and you're seeing this guy, some other characters, and you hallucinate. Okay, so they say to you, this is what the some concept artists came out for Ignis. Delivery the file, maybe I don't know about this process. I would like to know, by the way. I don't know if these people in Japan invite high school students to these studios to show them how these games are created in order to motivate the little kids to continue with the pursuit of the science or other humanities. They should do that. At least with other games, these are so. Is these some projects that they would like to announce for the future? At this point, they can show the people, these little kids, the students, hey, let's come out with your teacher and we will show you how these drawings are made on real time. You will see a drawer doing this character. You know, they have a lot of animes and a lot of products. And I wish for that to happen in every country, in every geography. So the little kids are always motivated, are always feeling this amazement in their eyes, this brightness for them, this happiness of knowing what is possible and seeing adults not fighting but creating and building, right? That will be good for the kids. So instead of you delivering 90 degrees, this guy will have the hair over here, like this, like in the past. Thank you very much. See you later in the night.